Today's goal is to sketch transformed sine and cosine functions. So we'll start out with example 1. So before I even start sketching, what I like to do is mark it up. I notice that there's no coefficient next to sine, which means that there's a hidden or unwritten coefficient of 1. That's my amplitude. I also like to notice, okay, if the b value is 1/2, then the period must be 2 pi divided by b. So 2 pi divided by a half, dividing by a half is the same as multiplying by 2 over 1. It's reciprocal. So the period must be 4 pi. And then this minus 3 tells me that y equals -3 is the midline of the function. So when I'm getting started and getting set up, I personally like to start by sketching the midline and labeling it at y equals -3. And then I think about the amplitude. If the amplitude is 1, that means I'm going 1 unit above and 1 unit below the midline. And so my maximum values will be at -2, and my minimum values will be at -4. And if my period is 4 pi, well, I like to mark that out. That means I'm going to get that full shape, the sine function shape, which looks like this, in the space from 0 to 4 pi, and then I usually like to draw a couple periods so you can catch a sense of the function repeating. Now a sine function looks like this. So I like to highlight when I'm going to hit the midline, and really I should highlight the max and the min so I can evenly space it out. Period being 4 pi means I'm going to start and end on the midline, and of course hit it halfway between and have that max and that min. So I've got this shape. I'm going to connect them with a smooth curve. Again, I'm going to start and end on the midline and then hit that max and the min halfway between my points on the midline. The final thing I want to do is make sure I end with arrows to demonstrate that the function will continue it forever in both directions. You do not want to end with an arrow like this. It's not going to increase or decrease indefinitely, but you want your arrow to sort of reflect this shape, right? It's going to continue up on this curve. And again here, and it'll continue in that curved pattern. Okay, let's take a look at 2 more examples today. Sometimes they're going to provide a graph, sometimes not. Sometimes the directions may say, like, sketch 2 periods of the function, in which case ours would be great. If it said sketch 3 periods, you'd have to extend it out to 12 pi and keep going. So make sure you're reading the directions carefully. Also keep in mind, sometimes the graph they provide is kind of weird. Sometimes it doesn't seem to showcase, like, a couple of periods. It may be sort of an awkward cutoff. So again, let's annotate what we have here. -2 means that I have an amplitude of 2, and I also have that negative sign means there's a reflection across the x-axis. And since it's a cosine function, I know that cosine usually looks like this. If you reflect it across the x-axis, now it'll look like this. Okay, I see that there's no coefficient next to x written, so it must be an unwritten coefficient of 1. That means my b is equal to 2 pi divided by the period, but it's easier to use this equation now because I want to solve for the period. So I have 2 pi divided by that unwritten coefficient of 1, so my period must be 2 pi. And then finally, I've got a midline at y equals 2. Again, I personally like to start by drawing in the midline. It just sort of centers my work. I like to then draw in the amplitude, which gives me a sense of like my max and my min. Okay, now I'm thinking period. Well, this is a little awkward. I have the entirety, the space of a width of 2 pi, but I know that for a cosine function, it's going to look like this, right? So on the right-hand side, I'm going to get half of a period. So half of a period, oops, sorry about that. It's like straddling the y-axis is what I'm trying to say. And so the y-intercept will be at a minimum. A full period would go from minimum to minimum in this case, since it's been reflected. Normally a full period would go from max to max. And so I'm only going to make it halfway there. So instead of going from minimum to minimum, I'm going to go from min to max over here. So let's mark my minimum. Let's mark my maximum. And then halfway between this min and this max, you'll hit the midline. So I'll mark that point in here and then connect it with a smooth curve. On the other side, right, on the other side of the coin, if I had drawn another period in here so we can get a sense of like, here's my y-axis. On the other side of the coin, again, I'm not going to do a full period from min to min. I'm only going to do half a period. So again, from min to max. So here's a minimum point here, a maximum point here. You'll hit the midline halfway in between. And we're going to connect these again with a smooth curve. Finally, don't forget, the domain of these trig functions is negative infinity to infinity. We indicate that by putting arrows at both ends to demonstrate this pattern of, notice it's not going indefinitely up. This would be wrong. It's going to continue this curved pattern again and again. Okay, final example for today. F of x equals negative 1/2 times the sine of 3x on the graph below. Okay, so again, I've got this negative sign, means there's been a reflection across the x-axis. The 1/2 is the amplitude. Amplitude is the height, so we always consider it to be a positive value. We can solve for the period. Will be 2 pi divided by b, so in this case 2 pi over 3. Oh, interesting. And then there's no number written here, so that's the same as plus 0. So y equals 0 is going to be the midline. Let's start with our centering value. Again, look, the graph they gave us is kind of weird. It's not going to have a centered picture, but that's okay. So we're going to do our amplitude will be 1/2. This must be 1 if this is 2. And so 1/2 is going to take us here and here. And our period is 2 pi over 3. So you can do that a couple of ways. That means 2/3 of a pi, so you can approximate it here. You can also say, okay, if this is 2 pi, I've got to fit 3 full periods in, so you can sort of like guesstimate where you'll end up. Okay, so there'll be a full period here, a full period here, and a full period here. If the period is 2 pi over 3, that means in the space of 2 pi, you fit 3 of them in there, okay? Or one individual period ends at 2 pi over 3. This, of course, would be 4 pi over 3. Another 2 pi over 3 would be 6 pi over 3. Oh, that makes sense. It reduces to 2 pi. Okay, sine usually looks like this. But if you reflect it across the x-axis, getting sloppy here, it'll decrease before increasing. So let's mark those points down. You're going to start and end on the midline, meet the midline halfway between. This time I'm going to go down to a min and up to a max in between. So it'll look like this. Unlike the last graph where we didn't even really get one full period to the right of the y-axis, this graph is going to allow us to fit in all kinds of periods. So you see many, many full rotations, right? And you can't leave this space empty. And it would be sloppy to just like throw an arrow in there. Let's always fill the graph. You want to fill the space with as many cycles as you can fit. So let's do negative 2 pi over 3, negative 4 pi over 3, and then negative 2 pi. And again, I like to sort of draw in at least a couple points to anchor me. I'm going to go decrease and then increasing going left to right. It can be sort of an approximation. This is obviously not a perfect curve, but it does give a pretty clear sense of amplitude, midline, period, and general shape. Oops, again. See, I'm getting sloppy. I should draw in these maxes and mins. They help center me. And we'll go to the very edge of the graph and then put arrows that go in the direction of the curve to indicate that this shape will continue forever and ever in both directions.